Hey, what's up, guys? So today we're going to be talking about systems and more specifically how to graph systems, or excuse me, how to solve systems by graphing. Um, there are Khan Academy videos that go a little more in depth on it that have more examples and whatnot. If you feel that you need more examples, feel free to let me know. But a lot of the videos I'm going to be coming out with are going to be purely concept videos, meaning that all they're going to do is they're going to just kind of go over the concept very basically with maybe one or two example problems, and then hopefully you can use that to work from there. If you want example problems, you're more than welcome to message me, and then I can either create a video or something like that. But this is purely meant for people to kind of get in, watch a quick sub 10-minute video, get out and start trying out the basics of their lesson, see if they can put it together. Okay, so with that, we're going to jump right on in to systems. So getting started, what we know is systems are just two equations that are true at the same time. What we know about systems is it's just two equations that are true at the same time. So for example, we know equations are things like y equals 2x. That means that whatever x is, y has to be two of them. But we might also have something like y is equal to x plus 15. And what that's telling me is that whatever x is, y adds 15 onto it. And if both of them are true at the same time, it limits the amount of possible solutions that we can use. So that's the general idea behind systems. All systems are saying is we have two equations that should be true at the same time. All right, now moving on with that. This is the general concept. Basically, let's look at this idea where a lot of you guys have seen Venn diagrams before, and what Venn diagrams do is on the left side, it gives you a circle that has Maury on top of it, and what that's telling you is these are all of the movies that I want to watch. The right side has Maury's sister, and these are all the movies my sister wants to watch. Now, anything in that right circle, just visually looking at it, is going to be telling me these are the movies that my sister wants to watch. So let's just kind of list them. Avengers Endgame, How to Train Your Dragon 3, Lord of the Rings, Fantastic Beasts and Where to Find Them. So if we kind of just pop those on there, this circle is telling me, hey, these are all the movies that my little sister wants to watch. Now, if you look at all the movies that I want to watch, we just kind of put them in that other circle. Now, for here, what we're going to do is both of these lists have Lord of the Rings on them. And this overlap here says that not only is it going to be on my sister's list, but it's also on my list. And the only thing that fits that is the Lord of the Rings. So this would be like a very basic idea to systems. The top list is all of the possible solutions for what my sister wants to watch. The bottom list is all of the solutions that I want to watch. And this Venn diagram shows us, okay, left side, right side, and the middle is where our two lists overlap. What movies do both of us want to watch? So if we're going to watch movies, we'll just plop down for 15 hours and watch Lord of the Rings. Now, math concept. This is kind of what's going on with our math concept. We're given two different equations. Again, a system is where we have two equations that must be true. So what we know here is that y equals 2x has to be true. And these are three examples. They're not all of them. They're just three examples. And then we also know that y has to equal x plus 2. Again, these are three examples. Now, the first one should have been 0, 0, but I typed it up wrong. I PDF'd it, and to me, sorry, I'm not going to go back to fix it. It's just a quick example anyway. So this first one is 0, 0. And what it means to be a solution is that when we say y equals 0 and x equals 0, it'll make my equation true. 0 equals 0. Yeah, this is totally true. That's how we know it's a solution to this first equation. But because it's a system, that means it has to work for both of them. So if we try it out, 0 equals 0 plus 2, 0 now equals 2, and that doesn't make any sense. And because it doesn't make any sense, we can't say it's a solution. So even though it might be a solution to this top one, it's not a solution to the bottom one, which means that we're going to put it in our left circle, 0, 0. That's a solution for this left one, but it's not a solution for my right one. That's the general concept between how we're using Venn diagrams to help me organize my solutions. So basically what you're doing here is you're looking for what is the pair that's on both lists. And that's going to be 2, 4. It's on this top list here. It's on this bottom list here. So 2, 4 works for the first one and it works for the second one, which means that this is the solution to our system. The solution to my system is the number that works for both of them. That's the general concept behind systems. Now, how do we actually solve it? Because very, very rarely are you going to be given a nice list like that where it's asking you to say, okay, what are all of my solutions? Here's one list, here's the other. Look for it. what we can do is we can use graphing, because again, graphing is just a visual representation of our solutions. Now, I'm going to be doing quick graphing. If you need to do slow graphing, that's fine, but quick graphing makes this so much easier. So this is one way that we can solve it. And what we're going to do is I'm just going to graph this top one with a black pen. So we're going to say y equals 3x plus 4, and the first thing we know is that my starting point, my y-intercept, is going to be 4. And since my slope is 3, that means we rise 3 and run 1. 1, 2, 3, run 1. So we go up 3, right 1. That's our little bunny hopping. Then we're going to get over here. Then we just draw my perfectly straight line, which I'm capable of doing. And then this is our line. Now again, the reason why we draw lines is lines are visual representations of all of my solutions, which means this line here visually shows me, hey, all of these numbers are solutions. So now we're going to do the same thing with this second one, and that's going to be in green. So we're going to put 2 here. So then we're going to say up 9. So this was 4, 5, 6, 7, 8, 9. That's up here. And then it says to go, my slope is -2. So that means we go down 2, right 1, down 2, right 1. And then we just draw, again, my perfectly straight line. And if you notice, there's this nice little overlap here that I'm going to highlight in red. Now again, if black is where all of my solutions for the first equation are, and green is where all of the solutions of my second equation are, then that means this red is the overlap. It's where it's true for the black because it's on the black line, but it's also true for the green because it's on the green line. If I were to look at this solution here, sure, it works for my first equation, but it doesn't work for my second equation. That's why it's not a system. So again, basic concept, in order to solve a system, you're looking for what is the solution that works for both. The way we're going to do that is we're simply going to be graphing our two lines and looking for the overlap. Now, if you notice, this was a relatively quick problem, but that's only because I'm really good at doing my quick graphing, which is why it's important, so important to do quick graphing. If you do the slow graphing method, you can do it, but it would take a lot longer just because you have to write things out and plug things in. It's a lot of extra work. Now, unfortunately, like I said, this is one method of doing it. It is not the best method, and it's honestly not a very good method, but there are a few pros. First off is it's easy to see visually. And it's really easy if you're good at graphing and you're given a really nice equation. However, unfortunately, a lot of times that doesn't work. So all it's good for now is just for us to kind of see the concept and to kind of get the general idea. The bad thing is if you're not given whole numbers, graphing is so irritating. And sometimes it just doesn't line up nicely. If it didn't line up so nicely on that overlapping spot, then that wouldn't have been a really easy thing to do. We would have had to kind of guess it, and if we're guessing, that's not our actual solution. So that's why it's bad for whole numbers. It's really often inaccurate because, as you can see, I'm really bad at drawing lines. If it didn't just so happen that that point overlapped for both, just because I drew the lines unevenly, that could have changed the answer as well. And a lot of you guys, whenever you have to graph, you kind of are like, oh, graphing so junk. And that's why it's even worse. So again, this is just to help you get the concept. If you don't love it, that's fine. We'll do something else in our next video. But for now, just know that this is a way that we kind of understand how systems work. So let's just, in closing, let's finish this off. 3 things that are super important to know. Number 1, systems are when you're given 2 equations and you're finding the answers. And the answers are where both of my equations are true. So you don't want a solution for one, you need a solution that works for both of them. The way we find it for now is we're going to just graph each of them and look for the intersection, look where they overlap. And if they don't overlap, what do you think that means? And if they completely overlap, what do you think that means? Finally, graphing is a good way to get the idea of systems, but it's not a great way of actually solving it. So if you need to solve by graphing, make sure you have that in your back pocket. That shows up on tests, it shows up on Khan Academy, and it also shows up on SATs and ACTs and standardized testing like that. So make sure you know how to do it. But whenever you're solving systems, we will be going over a better method. Okay, if you have any questions, as always, shoot me a message on Remind. Feel free to contact me, let me know. Again, this is meant to be used in tandem with Khan Academy, and we didn't go over many examples. So if you want more examples, feel free to let me know. I can actually do a separate example video if you guys want, but keep in contact with me. Let me know what's helping. Let me know what's not helping. I want to kind of tailor this to you because that's the nice thing about this distance learning. I can individualize it kind of a lot. So let me know if you have any questions. If not, see you later. Have a great day.